Hello students, welcome back to my channel. Today I will discuss about acids, bases and salts. This is the third lesson of this topic. If you haven't watched the first two lessons, then first go and watch those videos, then come back to this video. So let's start the lesson. In this video, I will talk about indicators. So what are indicators? Indicators are the weak organic compounds which can change their color according to the pH of the solution. That means when we will put an indicator into a solution, then what will happen? The indicator will change its color according to the pH of that particular solution. Now later in this video I will tell you about pH, but for now you know that indicators change their color according to the pH of the solution. Now when we put indicators into a solution, then those indicators dissociate slightly into the solution and they produce ions and undissociated molecules. Now the color of the ions that are produced by the indicators, the colors depend upon the pH of the medium. That means depends upon the pH of the solution, which in turn we can say it depends upon the hydrogen ion concentration. So we can say that when we put an indicator into a solution, then the color which the indicator will produce in the form of ions, that color of the ions will depend totally on the pH of the solution or on the hydrogen ion concentration of the solution. Clear? Now we will know what is pH. pH is the negative logarithm to the base 10 of the hydrogen ion concentration that is expressed in moles per liter. So in simpler words we can say pH equals to minus log base 10 of hydrogen ion concentration. Here see, I have put a negative sign just to show you that it's negative logarithm. So minus log, which is base 10, and of what? Hydrogen ion concentration. Here hydrogen ion has been written inside the third bracket. Here third bracket represents the concentration of the hydrogen ion. Okay, and this pH value actually represents the strength of acids and alkalis. That means whether the acidic solution is strong or weak, or whether the alkaline solution is strong or weak. And this pH value actually represents the strength of a solution depending upon the hydrogen ion concentration present in that aqueous solution. Okay, now see, this is a pH paper and various colors are present here. By looking at the color, we can say what is the pH value. How? See, this is the pH scale. pH scale actually represents the, or it shows the relative strength of an acid or an alkali. Okay, now see, 7 in pH scale represent that the solution is neutral. If a solution shows that the pH is 7, that means the solution is neutral. For example, pure water, it has pH of 7, that means it is neutral. Why? Because it ionizes very slightly to produce equal number of hydrogen ions and hydroxyl ions. As the concentration of hydrogen ions and hydroxyl ions both are equal in case of pure water, that's why its pH is 7. It's neither acidic nor basic, so it's neutral. Okay, but if we move towards left from 7, if we move towards left, then there is increase in acidity. That means if we take two solutions, one having pH 5, another having pH 2, then see, the solution having pH 2 is more acidic than the solution having pH 5. So the acidity increases towards left of 7. And towards right of 7, that means if we move towards right from 7, then the basicity or alkalinity increases. Again, if we take two solution, one with pH 10, another with pH 13, then what will happen? The solution having 13 pH is more basic than the solution with pH 10. Okay? So, this is the main thing about the pH scale. See, here is some pH values. For example, see, this is pH 7, the neutral of pure water. Okay, this is the pH of pure water. Now, see, when we move upwards from 7, then acidity increases. See, vinegar and lemon juice. In case of vinegar, the pH is around 2.5, and in case of lemon juice, the pH is around 1.5. So, we can say that lemon juice is more acidic than vinegar. Because what happens here? Here, the acidity increases. On the other hand, if we consider baking soda and milk of magnesia, okay, then see, baking soda has pH of around 7.5, whereas milk of magnesia has a pH of around 9 or between 9 to 10. So we can say baking soda is less basic than milk of magnesia. That means the alkalinity or the basicity of milk of magnesia is more. It is more basic than the baking soda. Why? Because downwards the alkalinity increases. Okay? See, here there are some pH values of some common substances. Dilute hydrochloric acid, HCl, pH is 1. Sulfuric acid, pH is slightly more, 1.2. Acetic acid, it's 2.9. Carbonic acid, 3. Tartaric acid, 3.5. Lactic acid, 6.6. So, as lactic acid is present in milk, so the pH value of milk is 6.6. It is very less acidic. Whereas, most acidic among them is hydrochloric acid, HCl. Carbonic acid is present in soft drinks. And tartaric acid is present in case of grapes. Now, for alkaline solutions, human blood, the pH is 7.3. It is slightly basic. Whereas in case of ammonium hydroxide, it is 11.1. And sodium hydroxide, it is very, very basic with pH 13. Okay? And the albumin, which is present in egg, it is 7.9. And seawater has a pH of 8.5. Okay? So these are the pH values of some common substances. Now, we will see what are the type of indicators that are present. There are broadly two types of indicators. One is common acid-base indicators and another is universal indicators. The common acid-base indicators includes litmus, methyl orange, phenolphthalein, etc. These are the three very common example of common acid-base indicators. What they do is they indicate whether the solution is acidic or alkaline. So by using this type of indicator, for example litmus or methyl orange or phenolphthalein, if we put this type of indicator into a solution, then this type of indicator only indicates whether a solution is acidic or basic, nothing more than that. That means this type of indicator cannot tell us what is the strength of that solution, how much acidic or how much alkaline a solution is. Okay, see, in the next point it has been mentioned that it cannot be utilized for the determining of the strength of acidic or alkaline solution. Whereas in case of universal indicators like the pH paper, it indicates the strength or the pH value, exact value of that acidic or alkaline solution. That means it will indicate how strong or how weak an acidic or alkaline solution is. Okay? So, a pH paper or an universal indicator can be utilized for determining the strength of the acidic or alkaline solutions. In case of common acid-base indicators, they cannot differentiate between acidic or basic solutions of different pH values. Why? Because they change their colors abruptly at certain pH value. That means they change the color abruptly, not distinctly. Okay. Whereas on the other hand, the universal indicators like pH paper, they can differentiate the acidic or basic solutions on the basis of pH value. Why? Because they give distinct colors or different colors with different pH values. Okay, that I have already shown you. In pH paper, there are various colors present. So, each color represents a specific pH value. Clear? Okay. Now, see, in case of the common acid-base indicators, see the change in color. In case of litmus, what happens? In neutral solution, it shows purple. Whereas if we put litmus in acidic solution, then it will become red. And in alkaline, it will become blue. In case of methyl orange, in neutral, it shows orange color. Whereas in acidic, it shows pink. And in alkaline solution, it shows yellow. In case of phenolphthalein, in neutral, it shows no color. That means it becomes colorless. It remains colorless. In acidic also it remains colorless. But in case of alkaline solution, it becomes pink. And there is another type of phenolphthalein which is alkaline phenolphthalein. Then in neutral it shows pink. In alkaline solution it shows pink. But in acidic it remains colorless. Okay. So these are the color changes of common acid-base indicator. Now, what are the utilities of indicators? See, the indicators are used in agriculture. The pH of the soil is tested for better growth of the crops. Like for example, in case of citrus fruits, okay, they need slightly alkaline soil. Whereas in case of rice, they need an acidic medium. And the sugarcane needs a neutral medium. So different crops require different medium. So for the better growth of the crops, the pH of the soil is tested. So in agriculture, there is an utility of the pH value. In dairies also, there is an utility. A change in the pH of the milk, we know that pH of milk is 6.6. So if there is a change of the pH from 6.6, then this indicates that the milk has turned sour. Then the quality of the milk is less. It's not good. Okay. In technology, pH values are utilized. Like biochemical and organic reactions are carried out under controlled pH conditions. And in case of medicinal purpose, pH values are also used. Like pH values of urine and blood are taken for the diagnosis of various diseases. For example, I have already told you the pH value of human blood is 7.3. So, here the pH value is very important just for the diagnosis of various diseases. Okay, so these are the utilities of the pH values. So, I think I have made myself clear and this topic is absolutely clear. This is all for this lesson. I will upload the next lesson of this topic very soon. Till then, stay tuned to my channel. And if you think my videos are informative and helpful, then please like and share my videos. And don't forget to subscribe to my channel. Thank you for watching the video.